Okay, now we're live. Okay, so what you see up here on the board, okay, it's not that it's old news, but I think I explained to one of you individuals, I gave you bad information. These actually can dehydrate, okay? They just can't oxidize, okay? Now, when you're looking at some of these alcohols, it is possible that some of them can't dehydrate because they just don't have the second part of that asymmetrical reagent part, because that's why, remembering that from last chapter, what some of these reagents are, just the idea that HOH looks like it's a mirror image, but no, because of the way it ionizes, it's an asymmetrical reagent rather than the symmetrical type. Okay, so you've driven, yeah, maybe you've driven them, I don't know. You've drawn these examples, primary, tertiary, and secondary alcohols is probably the most important aspect of this chapter, just being able to recognize them, because if you don't start in the right spot when you're using your flow charts or your whatever you want to call them, the handouts that we gave you that had the benzene in the middle, what do you just want to call them, flow charts or flow charts? Okay. Okay. Okay, so one of the things we see over on the board says we're talking about oxidations today, and I think we'll probably get to those, but from last chapter, dealing with the aromatic compounds, let's say you had, whether it was propylbenzene or isopropylbenzene, you oxidize that. We remember it was on your flow chart, it was the very upper left hand corner, because this reaction is so unique to the rest. Yes, KMNO4 or CR2, no, KMNO4, K2CR07. Those are very powerful oxidizing agents. One of them is dichromate, the other one's permanganate ions, and what that does is when it oxidizes that, it breaks all those chemical bonds, okay? So the reactivity, of course, is going to change with the different types of geometrical shapes that you would be dealing, okay? And just think it, at one time, if you were watching, even it was called The Men Who Built America. Maybe you spent some time viewing that in history class, or maybe yes, maybe no. Okay. Just think at one time when oil was, it's not so much that it was discovered, but here in the U.S., when we finally got it refined, excuse me, there was a lot of waste products in the form of octane, which of course is a hydrocarbon. We certainly know that it's got a very low we know it's got a very low boiling point, and just because of how it flashes. And at one point, when this oil was refined, this octane was viewed as a waste product, so you just dump it in the water. Of course, now, of course, that would be highly illegal, but just some of the characteristics, we know that that would certainly float on top of the water because it's insoluble, as opposed to alcohols, as we know, are very soluble in water. Okay. And with a lot of these, especially when it comes to inorganic chemistry, uh, it it's usually all about the hydrogen. Okay, but in this class, we said it before, it's all about the what instead. It's all about the water, of course, which has this hydrogen in there. Because water doesn't want to play by the rules because of that hydrogen bonding inside of it. Because, as we know, them ions, those hydrogen ions, they start to spread apart when you get below water's freezing point. Of course, that's when they start to spread apart. For everyone who knows, don't fill your water bottle to the top and put it in the freezer. Okay? Mm-hmm. That's a good way of pew, or however you said that. Yeah, okay. So, yes. You froze that before? Oh. Oh. Okay. All right. Okay, now, as we look at this, okay, this is kind of a neat way of looking at things, and I think one of the ways that the body detoxifies itself is when you look at that bottom point, okay? Since alcohols are soluble in water, remember ethanol is toxic to the body, okay? It certainly acts as a depressant, and we talked about this in your A&P class. That's why you see some of them sobriety checks, of course, because this alcohol slows your reaction times down. So if it's toxic to the body, which it is, one of the ways we get rid of that is because that ethanol then is water soluble. But in order to get rid of that, it takes a lot of water to do that. So for some of you who experience this 3 and 4 years down the road, because I'm thinking 18, 18, and 17, correct? Okay. So then once you reach that that age of 21 and that rite of passage in college to where it's legal to go do this, the more alcohol that someone chooses to consume, not saying it's a right choice or a good one, but the amount that they decide to take in, what comes in has to go out. But in order to do that, it takes a lot of water to grab that alcohol and get it out of the body. Okay, but it's a complex way. The liver will help you out too. Okay, but it's going to start converting some of that to sugars, and that's not always a good idea either. Okay. Like we just said, the liver will help detoxify these substances. Okay, multiple OH groups can grab a lot of that alcohol and get rid of it, but it takes a lot of water to do that because that makes it's water soluble then in urine. Have you cut your nails yet? Oh, they're not that long. So, well, sorry, Jordan, you're out of the loop because looking at those, we got Catwoman, and let's hear our best. I'm Batman. I'm Batman. I'm Batman. Yeah. Yeah, and that doesn't come from the movie, oddly enough. The comedy, The Big Bang Theory, where Sheldon he has to tell a secret where he goes, "I'm Batman." So I do that at home, and I get in trouble a lot. So yeah, yeah, yeah. The dog, he doesn't like it when I do that. Yeah, I'm Batman. I'm Batman. Yeah, yeah. No, but it's the other half who just would you knock it off? I hear that a lot. So yeah. Anyway, okay. So we don't have a whole lot left. Okay, here we go. So this transformation, okay, this intramolecular dehydration. That sounds like it's a very complex concept, which I suppose if at a deeper level you had to explain it, but we will show you what's actually happening here. So you bad information when it came all alcohol, molecular dehydration. But again, here's some exceptions to the rule. If there's no adjoining hydrogen, then it can't be dehydrated. Now, the practical applications for that would maybe this is a way to an ingredient for maybe making plastics, because when you think of plastics, it's just a polymer known as polyethylene. Okay, so when you do a chemical analysis of a lot of the organic compounds, I really wouldn't know what a lot of the individual ingredients are. So, but and it is mind numbing, and you've seen this example before. It's one of the things I show you when we get to the. I didn't know if I showed you this book at the freshman level or last year. It's not a naming book. It's one you can order chemicals. These are all of, and I don't even know if these are all the known organic compounds, but you'd seen the print in here, which is, as you can see, quite small. And when we do that, some of the last ones, even just letter V, I'm up to page 2507. You feel that's exactly what? Oh, yeah, I would say. But one of the funny things about that, you say, that's why the internet was created, and that's a good idea. I remember there's an old episode of Law and Order where a district attorney was looking through the law books, and an assistant goes, "You can find all that on, I don't know if it's a program called Westlaw or if that's even one, but it just means you hop on the computer, look for a specific case, whether it's a keyword search or something to that effect." But says, "No, I like the books," and I think there's something to be said for that. I mean, it's more time consuming, but I can't remember, we had a conversation before with, but the amount of Kindles that people use, is those starting to taper off? Does anyone even like Kindles anymore? Okay. But to me, the only thing that I think would make sense for that, well, a lot of things, each individual is going to be different, but just the idea, if you have that Kindle, you purchase that book, then you always have it. It's nothing you have to put on a shelf. It's nothing you have to return to a library or to a friend. You just you just continue, and you can go back and read it at any point in time. Okay. Okay. Then finally, okay, um, here we see, of course, these are all combustible. Okay. And then finally, selective oxidation. Okay, that OH group is oxidized. In other words, what happens is you're going to pull that hydrogen off of there. And tertiary alcohols do not oxidize. Again, we're going to go over a couple of examples here. and that will be it for today. So that way, when tomorrow rolls around, we'll be able to hand that paper out and continue uh, moving forward. Was it crazy that midterms is here? Is it going too fast for you people? When? Right now, this week. So, and talking to Mr. Hoth yesterday, you know, it's one of them things to where for him entering this year, and even you could say the same thing for you individuals. You know, he started the last year where you could barely see there's a little bit of a light down there, and then when the year started, holy cow, that end of that tunnel just got blown wide open. So I don't know if you look at things that way. It's kind of like, holy cow. We've only got 18, 19, 20, about 20, 21 weeks left for you people.
What?
That's probably about right. There's probably only about 21 weeks left.
What?
Yeah. So next semester, it's not even 18 weeks. It's probably only 17. Then there's 2 weeks. That's 19. And then next week, yeah, there's probably only 20 weeks left. So just simple math, that's 100 days, and that's not counting your Christmas breaks, your Easter break, spring breaks. So you're starting to eliminate days here and there, and we're going to start winding down pretty quick. And I know it doesn't, it sounds like it's a long ways off because Christmas is even here, but yeah, it's that's probably because you're too busy. Okay, so what we see happening here is go ahead and you can somebody put my markers out of order here. Okay, one of these black ones had it. So I feel like, man, that puts something in common with Allie and myself. Oh, I come back and it's not that I expect, but I usually visualize the markers in the same order I left them. Oh, no. Belongs there, and we'll put him here. Okay, so it's no big deal, of course. So give me any number of an alcohol. Okay, so then what type of hexanol do we want to be dealing with? Okay. Two. Did I interpret what you had said correctly? I thought you said 2-methyl and then diol, but we need to know where they're at. Okay, so that would be right then. Okay, so with this, a dehydration reagent is sulfuric acid. Okay, so we'd add some of this. I was just going to write SA for sulfuric acid, but that's fine. And probably a little bit of heat. So, what we see happening here is when intramolecular dehydration takes place, which I don't have enough room. Sometimes I probably don't need to write these that big, but I just want to make sure that you can see it from where you're at. So, what happens to these guys? When you dehydrate, we already know that what's happening. You're losing the water. So this gets stripped off, and for our practical, oops, I meant to take the bond along too, because that would disappear as well. Okay. So what we see happening then is if those bonds are disappearing, this is just half of that asymmetrical reagent you talked about. So then what has to be stripped off of there as well? Yeah, so adjoining hydrogens. So I would be led to believe that it would form in equal amounts. If you're asking, do we go left or right? I really don't think that matters. So, and that's the way that we're going to approach that, and we'll make sense of that in just a moment. So, left or right? Left or right? Okay, so now inside the boxes, we see we've got 2 molecules of what coming off of there? 2 molecules of water. That's right. So then when you rewrite this then, okay, this loop will come all the way around. Okay. So what's happening on carbon 1 here? Okay. And notice, since that's in a box, that came off of there. And let's see here. He's gone. And those 2 are still here. He's gone. He's still there. And then this one's gone. That's still there. And then those 3 are still there. It's not quite right yet. That one? Okay. So it doesn't, it's kind of, can you see that from back there? That light blue? Okay. Now, the reason that we say that way is, if you remember from last chapter, said we would make sense of that in just a moment, is the idea of if we had 2 butene, and if we're going to react that with whether it's the symmetrical type or asymmetrical, the asymmetrical type, we'll just even use HCl as an example. Excuse me. So does it matter, do you think, where these will bond on here? On the whole chain. Well, okay, I'll show you what I mean here. So we can safely put all of those on there now. Jeez. So my point is, what do you want this to be? Is this going to be, is this hydrogen or is this chlorine? Okay? Jeez, I can't write today. I can't talk. I can't read. Let's just all go home. Okay? So if a chlorine went here, well, then the hydrogen goes there. Well, who's to say, why can't the chlorine go here and the hydrogen goes down there? They can't, because it's in equal amounts. So my point is then, is that who's to say that that hydrogen gets stripped off or this one? It's going to form in equal amounts. We're not making up new chemistry here. I don't believe so. Because I know them Democrats, they can do a lot of things, but they can't make up new stuff. They might try, but all right. But anyway, so that's what we're trying to say. This intramolecular dehydration, you're taking a half of the molecule off on each side. So is that going to make a difference in whether it's a primary, a secondary, or tertiary? Well, yeah, only with the primary type, because it's all the way out there on the end. So it has to go to either the left or the right. That's the adjoining carbon. So if it's on the right, it can only go 1 to the left. It's all the way to the left, it can only go 1 to the right. Okay. So very quickly, just so we have a little bit of an exposure to this, okay, we're going to Are your flow charts handy by chance? I just want, like I said, just a little bit of an exposure. Okay, we're gonna just do, you'd think we'd start with the most simplest, the primary alcohols, but we're actually gonna look at a secondary alcohol just because the, the pathway that primaries go through is a little more, let's say, extensive. So that's why we want to do a secondary alcohol. So, someone give me an example of a secondary alcohol. So how many carbons in the chain? Okay. So then if it's going to be a secondary alcohol, there's only one spot where that OH can go. Okay. So if this is going to be an oxidizing reaction, which it will be, okay, we're going to add some KMNO4. So what you're going to want to do is on all them list of reactions, look where it says, it should say oxidation of primary alcohols and oxidation of secondary alcohols somewhere. Okay? So when you see that, notice it doesn't have something like R on there. Okay? Those R's are all alkyl groups. That's what the variable R is. And then if you're adding this dehydration, or not dehydration, oxidizing agent, okay? Remember we said that is stripping that hydrogen off of there, okay? So when it does that, okay, we're still going to have this 3 carbons, okay? But that hydrogen disappears, and then there's also going to be this guy that, oh, I got to think about this. Yes. That guy disappears then as well. Because what does it show you your end result is? Okay, which is which organic family? No. No. See, now this is where, remember the first week we were going through those organic families, and I understand it was a while ago, and I wouldn't expect you to know, I don't want to stand up and say, you're wrong, until we say ketone, yes, you are correct, okay? So finally, what we see then, not finally because you got the right answer, I mean finally the end of the reaction here. That's what I mean. Don't understand that. So then, like we said, that guy disappears as well. So this oxygen stays, but in order to make that a ketone, what has to happen? We have that oxygen, but there's got to be a double bond on there. So this is one of those aspects to where we say when oxidation reactions take place, that's why tertiary alcohols won't oxidize. Remember, we say X marks the spot, because if we were to say this tertiary alcohol, if we're going to take this hydrogen off, we say X marks the spot, is there an adjoining hydrogen like there is on this secondary one? On this secondary alcohol, we could take that hydrogen off. But is that a hydrogen atom down here? No, it's a carbon-to-carbon bond, not a carbon to hydrogen. And that's why tertiary alcohols do not oxidize. Okay, so we went a little longer than I would have anticipated, but that's okay. We will pick up with this next time.